The universe is a vast area filled with astonishing entities that never cease to amaze even the most brilliant astronomical brains in the world, from its expansion to its acceleration due to dark matter and energy. The dark, horrible, yet amazing secrets of the universe are within its boundless reach. Supermassive black holes, which can have masses equivalent to billions of suns, are most frequently found in the galactic center and were predicted by Einstein's theory of relativity. These enormous and mind-boggling objects are thought to exist at the center of every single galaxy, even the smallest ones, although scientists are still unsure of their exact origin. Although these cosmic bodies can weigh more than small galaxies and consume galactic gas, dust, and stars, there is some good news. Understanding how quickly a black hole feeds, calculating its mass, and measuring the amount of radiation around it allow researchers to now determine when some black holes experience their largest growth spurts. This information can reveal a great deal about the black hole's history, as brand new photographs taken by NASA's James Webb Space Telescope advance our knowledge of some of the most potent forces in the cosmos. The mystery of supermassive black holes at the stage of rapid growth known as active galactic nuclei, or AGN, is being clarified by a separate Dartmouth study. These supermassive black holes can emit a range of colored light. Additionally, they may vary in brightness and spectral signature. In the late 1980s, astronomers discovered that AGNs might be the source of light signatures from space that range from radio to X-ray wavelengths. The objects were thought to typically be encircled by a torus. Torus is a ring of gas and dust that looks like a donut. A unified theory of AGNs quickly gained acceptance because it explained how the various brightnesses and hues associated with the objects were thought to be caused by the angle from which they were observed and how much the torus obscured the view. According to this, if a black hole is viewed through its torus, it should appear faint and bright when viewed from below or above the torus. The latest study, however, calls this concept into question. The new Dartmouth study found a direct correlation between the amount of dust and gas surrounding a supermassive black hole and how rapidly it grows. A black hole will appear brighter and less shrouded when it feeds quickly because the energy drives gas and dust away. This research provided some of the strongest evidence of fundamentally different properties can distinguish supermassive black holes with varying light signatures. No single factor can account for these changes, such as whether the observation was made through or around AGN's torus. This result supports the idea that there is a relationship between the structure and the growth of the torus structures encircling black holes. A decade-long study of the neighboring AGN by an international group using SWIFT and a high-energy NASA X-ray telescope led to the realization that the feeding rate, not the viewing angle, controls the light signatures of supermassive black holes. Scientists have long held many assumptions about the physics of these objects, but they now know that heavily concealed black holes behave very differently than obscured AGNs. One of the most critical questions to plague the minds of scientists is how these supermassive black holes form. This new study offers a crucial element that might help researchers find the solution. They differ from other animals in more ways than their size and feeding habits. It is absurd that these supermassive black holes have been theorized to create new universes, especially since we cannot determine whether there are any other universes. A very simplified explanation of how this works is that our universe today has some incredibly convenient circumstances that came together to develop life. We wouldn't be here if you change any of these parameters even the slightest bit. The singularity said to be at the center of every single black hole violates the basic laws of physics, and in theory, has the potential to change these conditions and generate a new slightly altered universe. That being said, the idea behind this is still being researched today. From being an object that can consume planets and starts to something that creates new universes, it just gets crazier and crazier. Simply put, the madness doesn't end well. Stephen Hawking made this astonishing discovery in 1974. The phenomenon is known as Hawking radiation, and to fully comprehend it, we must first comprehend two concepts. First, a black hole has an event horizon. Anything that crosses this line, a certain distance from the black hole's center, is sucked into the black hole and never returns. Second, a particle and its antiparticle can spontaneously form in the darkest vacuum of space for no apparent reason and then instantly destroy each other, vanishing completely and leaving nothing behind. Energy is drawn from the vacuum during the destruction process and then released. Strangely, this appears to be the case, but given this knowledge, it's assumed that you're somewhere near a black hole's event horizon. A particle and its antiparticle suddenly appear from nowhere. Still, as they are about to destroy each other, one is drawn into the event horizon of the black hole and disappears forever, and the other escapes by the skin of its teeth. The energy taken from space at that time is not given back. The black hole's energy mass must be reduced by an amount precisely equal to that of the lucky particle that escaped it to compensate for this energy loss, ensuring that the universe's overall balance is maintained. As a result, we observed a continuous weak stream of lucky particles ejecting from black hole at any reasonable distance from it. In contrast, the mass of the hole itself gradually decreases. The escaping particles is known as Hawking radiation, named obviously after Stephen Hawking, and the black hole's gradual loss of mass is known as evaporation. Large star-sized black holes will find plenty to eat to keep growing larger and faster before evaporating. Still, for smaller ones, evaporation can be quick enough to cause them to vanish entirely and in a relatively short period. Speaking of finding plenty to eat, scientists have discovered a disturbing habit of black holes. They are messy eaters. Researchers have discovered how black holes consume stars and lose some of what they consume. The massive black hole at the center of our galaxy is a messy eater. You don't need to be so worked up. Black holes do not go planet hunting like hungry predators. Instead, these celestial bodies feed on a matter that orbits too close, such as one unfortunate star that scientists have been watching for the last decade being devoured. So how exactly do these cosmic spitballs elude a black hole's grasp? They are made of matter that slips from the accretion disk before reaching the point of no return and then solidifies into chunks, which is a fairly straightforward explanation. The large pieces that Sagittarius, a star, swallows have the potential to be thrown into our solar system at a rate of 20 million miles per hour. Fortunately, there are no known black holes that could collide with Earth. However, this does not mean that we shouldn't be worried, as supermassive black holes have been observed to occasionally hurl planet-sized spitballs that may be headed in the direction of our precious planet. That is our video for today. We hope you like it. Do you believe that these black holes could eventually cause us problems? Share all of your thoughts with us in the comment section below. Well, that's all for now. This is Big Tech Media. See you again tomorrow. Keep in mind to like, share, and subscribe.